Hey guys, it's just me, Mr. Wee. I just kind of want to continue on with where we left off for 5.3, connecting f prime and f double prime with the graph of the actual function f. Now we're going to start with an example here, okay, um, where you might be asked to do this. So here's the example. Your example is, what if you're given f of x is equal to x to the third power minus 12x minus 5, and then the prompt asks you to use the first derivative test, to find any extreme values. To find any extreme values, okay? So if you remember the first step, let's take a look back at our first step. The first step says to find the derivative of your function. And then your second step is to set it equal to 0 and find any x values that might give you a derivative of 0, or maybe some x values that might give you undefined answers too. It doesn't just have to be 0, but also undefined. Okay, so let's find, the first step would be to find f prime. So that'd be 3x squared, okay, at the power rule, right? 3x squared minus 12, and then the derivative of constant is just 0. So you'd get 3x squared minus 12. You can also rewrite that one more time if you'd like. Or you could just leave it like this. It doesn't really matter. But you can also leave it as 3 times, distribute out, or factor out the 3 out of 3x squared and 12 to x squared minus 4. So you can also look at it like that. Doesn't matter. You can use either or. Second step is to set this equal to 0. So set it equal to 0. And solve for x. Or what you could also do is see if there's any values that will give you undefined answers here for 3x squared. So, like anything, is there any values that we can plug into x here that give us an undefined answer? And the answer is no, unless it was like something like x plus minus 3. Like you had some bottom portion where you can't divide by 0. Like if you plugged in 3 in here, 3 minus 3, at x equals 3, it would have been undefined. But that's not the case. We don't have a bottom portion here. So there is no x value that gives us an undefined answer. Also, please remember in step 2, that I told you to look for critical values as well as testing your endpoints. But the truth is, were you given any endpoints here? Were you given like, this is f of x, and then you were given the interval from like 1 to 5? No, we were not given that. So truthfully, there are no endpoints in this context, okay? As we know, x cubed minus 12x minus 5 should be a continuous function. So we don't have to worry about any endpoints. Anyways, let's go back to here and solve for any x values that can give us 0, in which there should be. So in order to find that, we're going to do some simple algebra. We add 12 to both sides. So we have positive 12 is equal to 3x squared. Then we divide both sides by 3. And you get 4 is equal to x squared. And you take the square root of both sides, and you get plus or minus, technically, 2 is equal to x. And that's very significant because that tells us two potential places on the your graph that are potential critical values, and meaning that you could have some kind of extreme values there, okay? Critical values that might give you extreme values, okay? So here is the next part. So we're going to do like a number line here. And I know that, let's say that's set equal to 0, and then I'm going to do 2, and I'm going to do negative 2. And what I'm going to do is I'm going to see how the slope, so these are, what is it? These are the critical values, and then we're gonna like use this number line as a tool to figure out the slopes, whether they're gonna be positive or negative, like using f prime of x is equal to 3x minus 12, 3x squared minus 12. We're gonna plug in a point to the right here and to the left here, and to the right of negative 2 and to the left of negative 2, and see if it gives us a positive or a negative slope value or derivative value. So like on the right here, between 0 and 2, so 2 is the actual critical value and negative 2 is, we want to see if we get a minimum or a maximum here, okay? So here I'm going to plug in maybe like a number that is less than, less than, or I mean more than 2, so that'd be like 3. So let's just plug in 3 here. Let's just see what happens if we plug in 3 here. So we'll do f prime of 3 is equal to 3 times 3 squared minus 12. So you should get 3 times 9 minus 12. We get 27 minus 12. And then you get 15. So that's a positive 15. So we know that at this point, any number above 2, if you plug it in, 3 is just indicative that, it indicates to us that any number beyond 2, at least locally, right, like very close to 2, okay, at least, but it's a little bit above 2, they give you positive values, okay, positive values, which is a good sign, or it doesn't matter. It's just a sign. So now let's pick any number that is below 2. And actually, it's convenient because we could just pick 0. Just pick a really simple number. Because also, if we pick a number that's below 2, it actually happens to be above negative 2. So we can also get an inference about negative 2 as well, and what it is at that critical value. Is it a minimum? Is it a maximum? Okay, so let's do f prime of 0. And let's do 3 times 0 squared minus 12. Ooh, look at that. 3 times 0, which is just 0 minus 12, which is 0 minus 12, and our final answer is 12. So here, that tells us that the slopes between negative 2 and 2, or any number that's below 2 or any number above 2, should give us a negative slope. So this, to me, all right, if you remember from your book, I told you to look in your book. Let's see. If you're going from... Whoops, let's try to zoom in on here. So let's see what we have here. If it was a local max, we should have a, what is it? We should have a slope value to the left of your critical value as being positive. To the right of it has to be negative. So if we had that scenario, we would have a local max. Do we have that? With 2? No, it goes from a negative to a positive. So it's not a local max. So I think you already know what this might be. But if we look here on this scenario here, if at my critical value, if the slope around it is negative on the left-hand side and to the right of it is positive, it's going from a negative sloped area to 0 to that critical value, and it's changing from a positive. That tells us we have a local minimum. So we could say that here, this is a local minimum. Local min. So let's try out negative 2, because remember, negative 2, we can't automatically assume it's going to be a plus sign, and then it's just going to be like absolute maximum or a local maximum, because you could have this situation where on both sides you might have the same sign for slope, which means you have no extreme as non-extreme value. It's just someplace where the graph kind of just goes flat and then just keeps going on, but it's not like locally maximum, local minimum. So let's try maybe negative 3, I think is less than negative 2, so we can just do that. Let's do f prime of negative 3, which is just equal to 3 times negative 3 squared minus 12, and that will give me 3 times positive 9 minus 12. Oh, similar answer. Oh, sorry, that's 27 minus 12, and that should be a similar answer to what we had before at f prime of 3, f prime of negative 3. This gives us that our slopes to the right or to the left of this critical value are positive. So this should be a local max. Because if you look here, back at the diagram here, if you go from an area of a positive, hit positive slopes, hit that critical value, and then it goes to a negative, then you have what's called a local max. Okay, there you are. Hold on, we're not finished. We want to see, so now that we know that's a local min and max, we actually want to know the coordinate. These are just the x values. This is the x-axis. These are just x values. We want to find this as a point. So what this is going to look like is this. We're going to go back to the original function. F of x is equal to x cubed minus 12x minus 5. And we're going to plug in these two values. So at f is equal to negative 2, that'll give us negative 2 to the third power minus 12 times negative 2. Do some math. You can fast forward this part if you want. It should be negative 8 plus 24, I believe, minus 5, and that should give us 11. So the point here at 211, at 211, that's going to be your local max. Min, your local min, sorry. So that's the coordinate So that's the x value, and then we plug the x value back into the original function to find the, because remember, we're still looking at f of x, the original function graph, but we're just we're using the first derivative to find the slopes and stuff and the derivatives at various points to see what the f of x should still look like, because all this stuff is just helping us to look at the original function. So the other one is we're gonna plug in -2, okay, and see what its y value is. So it's gonna be, let's do some quick math, -2 to the third power minus 12 to the negative second power. Oh wait, did I do something wrong here? Whoops. Sorry about that. I did f of -2 already. You're dope. This is the local max. I am so sorry to confuse you. If you guys already caught it, you'd be like kind of like mad at me. Kudos to you, because I was wrong. This is the local max, -211, because we plugged in -2 already. So here, now we're plugging in +2 to find out the local minimums coordinate. So f of 2 would just be 2 to the third power minus 12 times 2 minus 5. That'll be, what is it? That's going to be 8 minus 24 minus 5. That should be -16. And wait, isn't it? Yeah, -16 minus 5. Is that correct? Let's see. Yes, I believe so. That should be -21, I believe, right? 8 minus 24. I can't believe I'm faltering on live camera or on recorded camera. Yeah, it's -16 minus 5. That's -21. So the coordinate would be 2, -12. That is your local min. Okay. Let's check this out in Desmos really quick to see if this all kind of works out. So let's go here. So I already graphed this. This is the graph of the original function, and let's see. Let's see the coordinate here. It looks like this is the local minimum value. 2, -21. Exactly. We found out the derivative here is equal to 0, okay? And we found out the coordinate, 2, -21. Now let's verify our other answer. Was the maximum, the local maximum, at x equals -2? More specifically, -211. There we are. Okay. All right, guys, that's it for this problem. But let me give you one more sample problem really quick so you can try it out. Try this one here if you want to try. I know it's kind of hard to read, but it's going to be f of x is equal to in the quotient of x squared minus 3 times e to the x. Okay, pause that. You can try that. You can see I want you to find any extreme values there. Test them. Okay, pause me, and when you're ready, unpause me, and then here are the solutions for you to check. Voila. So that's my work for, don't worry about the very, very bottom, just my work for here, so you can test it out. That's f prime. I know it's kind of hard to read, but it says f prime of x, and that's what I got here. Then I set it equal to 0. And I found these two values. Then I tested out on this number line, and then I actually graphed over this. So this is the x, this is x, and then secretly this is like where the y-axis should be, but you don't have to draw that in. Y-axis should be about there. This is the x-axis, and then I'm just testing out. This is how I did it. So on both sides of each critical value, I just figured out the slopes, and it follows it. I actually drew this is actually f of x right here. Like this line's actually just f of x, and there you go. Okay, guys, you guys have a great night. Okay, bye bye.